Okay, and if I could just welcome you all, good morning and thank you. Welcome to the Smart Energy Wins workshop with E3 Sustainability. And I'm one of Thrive's programme leads, Mary Fraser. And I'm really, really thrilled to welcome David Legge of E3 Sustainability. He's a specialist buildings consultant. And he's able to join us today to share his extensive knowledge and experience in the sector, um, particularly with community buildings, but right through the voluntary community faith and social enterprise sector as well. David, this year in year two of the Decarb Somerset programme, is a project partner with us. And through the programme overall, he's helped over 30 buildings gain a really deep understanding of their buildings' energy usage and where improvements can be made. So those are buildings that have had audits, full audits through the programme. The Decarb Somerset programme I mentioned, it's funded by government's Share Prosperity Funds through Somerset and Somerset Council. And we are in our final weeks now of support in the second year of the project. We understand it won't be renewed in April due to funding restraints. Obviously, government have other priorities at the moment. There's going to be an opportunity to ask questions and introduce your organisation after David's presentation. There's going to be a Q&A session with David, and he'll be joined by Steve Grice, the Thrive Programmes lead for community buildings. So if I could ask you to mute your microphones for now, I'm going to hand over to David.
Thanks, Marie. Thank you very much. Good morning, all. Yes, so yeah, we've worked with Thrive for a good few years now, delivering a number of kind of different energy surveys and deep dives into different charitable and community organisations. And I also work with many other bodies, of course, a lot of which are kind of third sector and community based. So I'm just sharing some of the findings I find when I go around to some of these various buildings, and some of my experience over the last 15, 20 years of seeing what works and what doesn't work, and for you to hopefully take away some some quick wins that you can do yourselves. And then we'll also touch upon some of the kind of more some of the bigger projects, so solar, PV, and various kind of heating systems from a decarbonised point of view. There will be plenty of time to ask questions at the end because I know everyone will be having thoughts about what they want to do with their own building and organisation. So I will not spend too long kind of going through all of the slides, and we'll just leave enough time for questions at the end. But um, this is the general order of the day. So I'll start off with kind of where we should start, which is energy meters. So understanding what you use in the first place at all times. Now, obviously, we're moving towards smart meters, but a number of community organisations I still find with the kind of the old school meters, especially nothing with a pulsed output like we see in the photo there. Um, and this meter is a kind of typical day-night tariff meter. On the right-hand side, you've got the time clock, which dictates when the time of the night tariff comes in. Now, sometimes these can kind of fall out of calibration, or they can be installed incorrectly. One site I went to a couple of years ago had this exact setup, but basically their time clock was out by a day and the time was out. So what they thought they were using overnight was actually costing them probably around about £500 a year more than they should have been. Um, Obviously, if you move to smart meters on your electric and on your gas, then we should be getting very accurate readings from that direct to the energy suppliers, and then they should be billing you accurately every month, which saves kind of finding out, you've been in arrears, or they're overcharging you and they've got, a lot of your money to claim back. So a move to smart meters is always a good thing. Boiler controls. So we've got kind of a lot of community buildings will have kind of standard kind of domestic style boilers. Where we've got larger buildings, we might find a commercial boiler unit. And the picture in the middle of the two the two controls here as a dual burner unit, and these basically are demonstrating that we've got a low fire and a high fire flame. And a lot of the time, I go and see these boilers. People don't understand how they're meant to be set up correctly. They are designed to be two different dials, and the high flame should be the lower temperature than the low flame. But if somebody's got a boiler like that and they're slightly confused, I can talk to you offline about it because it's not as simple as going through it. Um, in terms of your kind of controls on your boiler, so the right hand photo you can see there, that control is essentially saying this is how hot the temperature is going to be running around my heating system. And most people would kind of recognize that from their home boiler, if not their organizational boiler. Obviously, setting it to max is going to burn more gas, oil, LPG, whatever that boiler is fueled by. Um, but equally, it's trying to find the balance of gas consumption and comfort within that space. And ideally, we're looking for kind of something where we're not turning it up to max, we're not turning it up to the highest setting possible to try and, you know, raise the temperature of that room or space as quick as we possibly can, because that essentially doesn't work. You know, the physics doesn't work like that. So try and find the balance, and it might be around the kind of 4 or 5 mark that you find a good flow rate from the boiler to enable the radiators to get warm enough to heat the space comfortably. The other thing I see a lot of the time is frost stats. So the picture on the left there, a frost setting really only needs to be above freezing point for an internal air temperature frost setting. We typically recommend kind of 3 to 5 degrees for an internal air temperature frost stat. The other way you can potentially kind of avoid using a frost stat is by putting a glycol inhibitor, i.e. antifreeze, into the boiler system, which avoids obviously the freezing of pipes. A lot of the time, obviously, if they're set to a higher temperature, and a lot of halls are using basically background heating, so they're setting that to a, we keep the unoccupied temperature at 10 degrees, 12 degrees, 16 degrees maybe. So there's nobody in there. It could be middle of the night. It could be a day when that building's not in use and it's still set to 10, 12, 16 degrees. Now, obviously, the higher that set point, the more gas, LPG, oil you're consuming to keep that building warm for the sake of nothing, as far as I'm aware. Obviously, if you've got a historic building and you need to stabilize that interior and you've been given specialist conservator advice around temperature and humidity having to be stable within that space, and you need to heat it to a certain temperature and you have humidity sensors in there, then that goes without saying you need to heat that building. But I went to a building a few weeks ago, built in the 1980s, 90s, and they're heating it to 16 degrees continuously through winter, and raising that up to kind of 19 or 20 degrees when they're occupying it, because that was what has always been done. You know, that was what someone said 5 years ago, 10 years ago. So they're just heating it. Um, I don't think there's any kind of real need to heat the buildings to a background temperature. Um, the stable temperature of a building, especially when community buildings are well used, if people are in and out intermittently but frequently throughout the week, you will naturally kind of have that building heating up and cooling down. But you will be introducing kind of air changes into the space as well, which helps to drive out humidity. And actually, ventilation tends to be a better solution to changing humidity in a building than it does heating it and driving out the damp as people perceive it. Obviously, if you have specific areas where there's damp getting into the building, it's treating that as root cause. So if you've got damaged rainwater goods or leaves in the gutter, or rising damp, that needs to be treated rather than just thinking, well, if we heat the building, we'll get rid of the damp. A lot of buildings now are moving towards internet-enabled heating controls, so moving away from the Drayton kind of time clocks, which I see in a lot of places, towards something which you can, multiple users can control on their phone, on their laptop, from the comfort of their own home. And good practice around that is to look at um, a week ahead schedule to see what's happening in the building that week, and just set the heating up to heat those those times when the building's occupied. Um, they're relatively cheap, I guess, to kind of buy and install. Your heating engineer can install those at the during the next boiler service, and it does obviously give you visibility when you're not on site, and it means you don't have to go to site to set up an additional 2 hour meeting that's happening Wednesday evening. You can do that in your pajamas, sat at home. Um, Timers. Again, a lot of the time, there are other elements in the building which can be controlled with time clocks. External lighting is a classic. Really only needs to come on at dusk, ideally with a photocell sensor that monitors the outside lux levels and then says, right, I'll only turn on when the lux levels outside have dropped below X. And then you set them to turn off at a given time. Kind of 11 o'clock is the typical, but it depends on what security measures you want for that site and what your neighbouring properties are. Are they residential? Are they next door to you? But really, kind of no later than 11 o'clock. And then you might have some kind of early morning lighting if you need that. For hot water units, so the kind of the under sink kind of point of use electric hot water units, which you see a lot of the time. A simple kind of time clock, 7 day time clock, like the picture on the left there. You can set again that up for the regular users, and there's also unfortunately where the finger is pressing the button, that is a boost button. So you press that boost button to get an extra hour of hot water. They take, they're essentially a fairly large kettle, so they take 10 minutes to warm up. But essentially, most users are trying to use that for hand washing in toilets or kitchen sink washing up, or a bit of cleaning, something like that. So the programmable kind of unit with a boost button works well. Some community organisations use just a boost button. So they come in and say, right, it's just press once for half an hour, twice for an hour, 3 times for 2 hours, and then it goes off. But it saves it just being left on permanently the whole time, which is very useful in an intermittently used space, because it's just trying to maintain a steady, 60 degrees temperature. So, albeit that they're insulated, it will, cycle on and off, and you use energy. Uh, Heat emitters. So your radiators, your fan convectors, keeping them cleaned, maintained, looking after them, putting your hand on them, checking they're working, will depend on a number of variables. But if we go to the kind of the pictures, the top left two kind of thermal image pictures is a before and after of a radiator which has been power flushed. So in the left hand image, can I use my mouse to get across there? No, I can't. Um, Technology is beyond me, I'm afraid. Oh yes, I can. Hopefully you can see my mouse swirling around a top image there. The purple area is cold, that is sludge in the system, and the white areas are hot, a hotter temperature. They've power flushed that radiator with a heating engineer who's come along and taken that radiator off and flushed it through, and then you can see the heat emitter is much greater. Afterwards, there's a lot better kind of uniform temperature through that radiator. The top right hand picture is the same effect essentially. It's just showing a great big kind of umbrella of sludge in that radiator which needs power flushing. Bottom left is a more simple fix which you can do yourselves with a radiator bleed key. The white at the bottom is coming in through the flow and flowing across the bottom and going out through the return. And the rest of this is air. That's just an air lock in the radiator, which I'm sure everyone is aware of. Just needs a simple bleed key at the top, let the air out. It might indicate that there is a leak in your system and your heating system. This can be resolved with a leak sealant a lot of the time, which you can buy and pour into the system, or your heating engineer can pour into the system, and it will find those kind of little weeps and leaks and seal them up. If it's something that happens regularly and you're losing a lot of water from the system, then obviously it needs more intrusive investigation to find out where that is. where the pipes go underground, that's when it becomes a problem. And the last image is this fan convector with the front taken off, just to show you what's inside a fan convector. And they just need kind of annual cleaning, where you just need to be careful where you're cleaning those fins at the top of the heater. You can buy kind of fin combs, but a vacuum cleaner with a gentle brush attachment will take off most of that dust and increase the effectiveness uh, of that fan convector, and that can just be done on a 6 monthly or annual basis as required. Pipe lagging. So boiler rooms tend to be quite a warm space, but people don't tend to want to have meetings in boiler rooms. They're not the most attractive spaces in the world. You'll find a lot of the time the straight pipes are lagged, but the joints, the unions, the flanges, the valves are not lagged. And they are essentially, you know, a lot of the time big bore pipe work because they're coming off the boilers before they go into the smaller bore pipe work around the building. And they're essentially acting like a radiator in your boiler room. Um, so there are companies out there which will come and measure up the different kind of knobbly bits in your plant room and bespoke make foil backed Velcro jackets to fit around these different flanges, valves, joints, and stop the heat leaking into the boiler room and essentially push it into the space where you want it. They're a relatively good return on payback for these because they're fairly cheap to make and install. And obviously there's a lot of heat leaking out, especially when it's straight off the boiler. So that's coming out at 70, 75 degrees and losing it straight into the boiler room before it even gets to a radiator. So that's a good measure to consider. Draft proofing. We've got windows and doors, which are the inevitable cause of drafts, and sometimes it's just around convection of cold air across a cold surface. Um, People always say, "Oh, if you sit next to the window, it's drafty." It's sometimes just the cold air is dropping down across the windows, and if you sit underneath the window, it feels cold. They might be, well sealed, double glazed units, and you still find that convection. However, doors, particularly kind of historic doors or doors which are worn over time, just you need to try and reduce the amount of cold air ingress into the building. We need to ensure that windows close well, that there aren't any blown double glazed seals. Obviously, if there is still single glazing and you're in an unlisted building, not in a conservation area, that we consider changing these to double glazed units. Thermally broken double glazed units, ideally with low E coating on them. Um, and then with doors, so a lot of doors have brush seals or fin seals on them. It's making sure that these are still working well. A lot of the time they're worn, you can see daylight through them. It's a case of replacing those. Um, Glazed doors are particularly a problem if you've got kind of fully glazed doors on a building. The architects like the fact that they're clean lines, but actually they tend to have very large gaps around all sides of those glazed doors. But you can buy kind of transparent fin seals, you can buy brush seals which you can clip on essentially to those doors to stop that cold air coming through. If you're considering replacing the doors in your building, ideally get the external doors to open outwards so that if the wind is blowing, they are pushing in to close shut rather than pushing in to blow open. Because if you have a particularly strong wind, they will, well, they will, they have more of a tendency to be able to blow the door open and allow lots of cold air coming into the space. Um, if you've got large kind of keyholes on old kind of wooden doors, fridge magnets can cover those and be useful. You know, get the local WI, Mothers Union, whoever, to make sausage dogs for gaps on doors which aren't well used. Obviously, if it's the front door, it's not going to work very well having a sausage dog in the way. Um, and then thermal curtains, blinds, anything like that after dark, or where the sun doesn't shine, basically. So north-facing buildings, obviously where the sun's coming in, you're getting solar gain through those windows. So if the sun's shining in through the windows, the curtains are going to stop that heat coming into the space. but certainly after dark or last users of the day, if they close the curtains, close the blinds, it will help to retain the heat within that building. Uh, Lighting, easy to change light bulbs. So a lot of spaces now are moving or have moved towards LED lighting, and that's the way everything's going. Um, there are most fittings really require a kind of change of the whole fitting. If you have a new whole fitting, they tend to come now with at least a 5-year warranty on that piece of kit. Um, I see the retrofit kind of fluorescent tube lamps in a lot of spaces that don't tend to have the same warranties on just the tubes. They are a cheaper kind of alternative, but they also tend to not last as long. So the balance is a kind of whole life approach to considering doing that. The lamps that we can see here are ones which you can change yourselves. Essentially, they don't need a new fitting. So the one on the left is a PAR 38 lamp, quite common. The next one we've got is a GU10 downlight, but it's a mains fitted one. And then the third one along, I don't know if you can see, it says Philips at the bottom with the two little tiny pins coming out the bottom, is a low voltage MR12 lamp, and that um, it shouldn't be changed lamp for lamp. That needs a fitting replacement. And then the last one is a standard kind of GLS light bulb. It's important to check, obviously, the fittings, whether you've got a screw fitting, a small screw fitting, a bayonet cap, and what the diameter of that is before you rush out and just buy a load of new lamps, because there are, B15s, B22s, SES 15s, ES 22s. So just check what the fitting is before you rush off to the electrical wholesalers to get those. I'll touch on water saving as well. It's still relatively cheap, but it all helps. And actually, if we're saving water, we're also, although we're sat in Somerset, probably thinking we're surrounded by water. Um, the water saving helps. And if you're saving on not just cold water, but you're saving on your hot water, that's helping reduce your hot water provision, whether that's electric, gas, oil, etc. A lot of these you can get free from the water companies, so Wessex Water. You can go online. You can look at who your local water provider is, and they can send out these kind of saver flush bags. They send out tap conversion kits, depending on what type of taps you've got. So the real old taps would need replacing with a new tap, but some of the newer taps you can take the head off the tap with this little conversion kit, which is shown in the picture, and you can install an aerated kind of bubbly airflow through it, which reduces the flow rate out of that tap. If you're considering moving to kind of new taps, then depending on the users and the problems you have, maybe in the hall, you could go for, the sensor taps you swing your hand in front of, or percussion taps you press and they turn off. But you want the flow to be fairly low coming out of those. In areas like kitchens or kind of big kitchen sinks or cleaners cupboards, it probably doesn't matter so much. And actually, probably what you do want is still a reasonable flow out of those, so you can fill a kitchen sink, a cleaner's mop bucket fairly quickly without them standing there for an hour trying to wait for bubbly water to come out at 3 litres a minute. Um, I'll move on to some of the kind of the bigger things which I tend to get asked about quite regularly. So I've got solar PV as the first one, and the second one is heating. And then we can open up for questions. So solar PV, essentially, generating electricity on site for your building. The balance on installing solar PV really, from a financial but also from an environmental point of view, hinges on how viable are they at that building, how consistently do you use that building to consume the electricity that's being generated by the PV. So you've got to consider your kind of your daily, your weekly, and your annual load. Obviously, the annual load is that in summer the PVs will be generating a lot more than they will in winter, and vice versa. You will be using a lot more energy in winter than you will be in summer. What we're aiming to try and get is probably around about 75% yield from your solar PV to make it financially and environmentally viable. The smart export guarantee at commercial rates or small business rates is less than what you get at the domestic level, um, and they vary depending on who that's with. But it then becomes financially unviable when you kind of drop below that to make it work. So the daily loads are basically looking at um, trying to get as much out of that system as you can. You can install batteries, obviously for use later in the day, for evening use, for nighttime use, or for early morning use if the space is in use prior to the sun coming up or the PV being able to generate too much. Um, but the solar PV needs to top up the batteries. The batteries need to discharge, and then the solar PV needs to top them up again on a daily basis. Otherwise, like I say, it just doesn't stack up. So that's the balance, and ideally, you want local kind of solar PV installers to come around. You want to be able to get three quotes and compare those quotes. Um, the best case scenario is you can provide them with a very detailed energy profile of what your building does day to day, so they can map out how much yield you will get from a solar PV array, and they should be able to then size an optimal PV array and possibly batteries to sit alongside how your building is used. And the conversations are to be held with them and the devil in the detail for them to model how that building is used and how the PV fits into it, and for you to obviously make that decision on whether PV is a viable solution. Obviously, from a carbon point of view, they're always great because they're generating energy on site. But you need to be able to consume a lot. The distribution network operators, which I think for probably most of us is National Grid, um, also have the say in whether you are allowed to have X, PV on your roof, especially if you're not consuming all of that on site. Net zero carbon heating. I could probably speak for hours on this, but I won't. I'll try not to anyway. So at the moment, most buildings I would say would have a gas-fired, LPG-fired, oil-fired boiler going to radiators or fan convectors in their building, and that's what most people are familiar with, and most people are used to. They tend to last 15 to 20 years, and it's really that kind of timeline which you want to look at and say, okay, if your boiler is, pre 2012, say, at this point, we might really start looking at we need to replace this. And even if it's newer than that, you might turn around and say, well, we still want to be net zero carbon in the short term. We want to look at replacing this earlier, or even we want to be able to agree as a committee or as an organisation that we are going to move towards X, and do your homework now before that boiler goes pop and you have a knee-jerk reaction of what are we going to do? Sudden panic. I know we'll just get a hydrogen-ready new gas boiler and install that instead. Um, I can't kind of shy away from the fact that a gas boiler is probably the cheapest thing you could install. And it's going to be the thing that everyone's familiar with. So people won't like to move away from what they know and what they're used to. But it consumes fossil fuels. It's going to be in place for the next 20 years. And actually, is it the right thing to do? Um, any new system is going to be dependent on a number of factors, primarily probably a building usage pattern. So how well do you use that building? What kind of usage pattern have you got? Is it Monday to Friday, 9 to 5, and therefore 40 hours a week? Or is it Monday morning for an hour, then the evening for an hour, no one's in on Tuesday, yeah, we're in on Wednesday for 3 hours. And then that will depend on what kind of heating system you can consider. And they all have their pros and cons. When we look at electric heating, I think I see it as two different kind of solutions. We've got a heat pump driven solution on one side, or we've got direct electric heating on the other side. Heat pumps are very good at a very efficient system. A lot of the heat pumps are good at being providing consistent heat to a building which is used for long periods of time. Electric panel heating is less efficient than a heat pump, but it's very good at being able to heat localized areas. So if you've got a large space, a large open plan office or a large hall, and you say, well, actually, on a Wednesday morning, people only sit in that corner of our huge hall, and they sit in a tiny corner. If you're using a wet heating system, a radiator system, you're heating that whole space. You're heating the entire building for 5 people to sit in a corner and play Scrabble or dominoes or have a meeting in a room. And that's where electric heating, direct electric heating, comes into its own. Um, with the heat pumps, essentially we've got replace your boiler and change it for the heat pump. So the heat pump is the new boiler. You've got air source heating, water source, and ground source. Ground and water source heat pumps tend to be a bit more niche. Water source because most places don't have a viable water source next to them, so they are very niche. A ground source heat pump tends to be fairly expensive to install, and tends to kind of go hand in hand with other kind of civils works, i.e., building a new building, digging up the land, laying a new car park. They have a high capital cost, so they tend to kind of be a bit more specialist. Air source heat pumps, you tend to have two kind of common themes. You've got an air to air or an air to water. The air part of it, the air source heat pump, is the same, essentially the same item. It's the same boiler, as it were. How you introduce the heat into the building is different. So on an air to water heat pump, you're putting it into a wet heating system, so your radiator system. In an air to air system, you're putting it through refrigerant pipework and then blowing it in to the building. So air to air is essentially air conditioning. So you have floor, wall, ceiling mounted units which are blowing air into that space. Air to air systems do it very efficiently. So they tend to have an efficiency around 400 to 450%. And they are very responsive. So they can heat a large space within 20 minutes, half an hour of being switched on. So they're very good for intermittently used spaces as well as continually used spaces. And they are very efficient. Air to water, uh, we'll obviously put it into radiators. They have to heat the whole space because it's a radiator system. They have a lower efficiency, so they're around 350% efficient. So still very efficient, but lower than air to air. But they like to maintain a continuous background temperature. So they like to be, sitting around kind of 14, 15, 16 degrees, depending on what everyone's comfortable with, and some of that's trial and error. And they are quite slow to respond to being switched on and off. The reason for that is their efficiency is driven by the fact that they have a lower flow temperature than your gas boiler. So a gas boiler will have a flow temperature around 75 degrees, which means those radiators in your building get fairly hot fairly quickly and are quite responsive to warming up the space. An air to water system will have a flow temperature around 45, 50 degrees to enable that efficiency. So therefore, you may need new radiators anyway. You may need bigger or more radiators to allow the same heat into that space, but they cannot heat as quickly as a gas boiler can either. And that's where you then get into high temperature air to water systems, where you either have a hybrid kind of gas boiler and air source heat pump in combination, doing essentially what the gas boiler was doing previously, but the air to water heat pump is doing most of the load, so it's doing 80% of the work to get it to that kind of 16 degrees temperature, and then the gas boiler ramps up to do the very quick responsive approach. An alternative is you have kind of two-stage air source heat pumps, where the first stage is a heat pump taking it from cold water up to 45, 50 degrees, and then the second stage is taking it from 50 degrees to 75 degrees. So again, you're replicating that kind of gas boiler system, but you're doing it with doubling up on your heat pumps, which makes the capital cost very high and the efficiency quite low. So it's not a common theme that you see going through it. With all of the heat pumps, they're all electric. They're all electrically driven units, and um, they're very efficient. But there has to be a consideration of if you're moving from gas, oil, LPG, and if we keep the numbers simple, it'll make my life easier as well as yours of understanding it, hopefully. So if we have gas at 6p and we have electricity at 24p, the electricity price difference is 4 times. So your heat pump will have to be 4 times more efficient than your current boiler for you to break even in operational costs. It's very price sensitive. So depending on how much you're paying for your thermal fuel at the moment, gas, oil, LPG, and how much you're paying for your electricity at the moment, will determine whether that looks like a good deal or not. And I've seen gas prices recently at sites where they're paying 11p for gas, which is pretty high. I've also seen people paying 20p for electricity. Um, and that would then make a heat pump look brilliant because you're going from 11p at gas to 20p electricity. It's great. But if you look at it on the flip side, if you have 4p for gas and you've got 32p for electricity, that heat pump has to be 8 times more efficient than your current boiler, which is a push too far. I can't kind of find things for you know it doesn't work. So they're very price sensitive, and it should be looked at with a long term view. So you should look at probably market conditions and what the prices look like before making a consideration on heat pumps. But they're not suddenly just going to save you thousands of pounds in operation. But what they can offer you is a responsive net zero, fully electrified heat pump solution. And if you take away the gas from your site, you obviously lose the gas standing charges and your gas maintenance of what equipment you have on site. If your boiler is doing your hot water, you'd have to move towards kind of electric, normally kind of point of use water heaters under the sinks in the wash hand basins of the toilets and for the kitchen. Or you can have a centralized immersion tank, and if you have solar PV, you can feed that into the immersion tank as well, on a kind of smart control that, if nothing else is happening in the building, it can feed into that tank. So that's one way of doing it. Um, Electric panel heating, 1 unit of electricity goes in and 1 unit of heat comes out. It roughly it's fairly simple. Like I say, they're great for kind of supplemental heating. So typically, if you put a heat pump in your main space, you might have just some small panel heaters in your toilets, or in your stores, just to take the edge off if you feel that's necessary. But they're very good at being able to do localized heat. They're very responsive. They can turn on and they can warm a an area up within minutes. But they don't have the efficiency of a heat pump. Um, they can also be controlled on time clocks or boost buttons. They are a lower capital cost install typically than a heat pump would be. And in spaces like halls, we tend to find we've got now the kind of the black light long bar heaters, so they're medium wave or long wave infrared heaters, which are trying to heat the objects, not the space. So if you sit underneath them, you feel warm, but they are not trying to heat the whole space. They're just trying to heat what they can see. So they just need to be sited correctly, but you know, they're relatively efficient, but they're a cheaper capital cost than the heat pumps, and that then comes back to the whole life kind of consideration of how much it's going to cost to install and how much is it going to cost to run, depending on your building use. Um, Electric boilers I've put in there. People have mentioned electric boilers as a direct replacement. Again, they are a one for one efficiency replacement. So you put 1 unit of heat in and you get 1 unit of, sorry, 1 unit of electricity and you get 1 unit of heat out. So if you're changing from gas to electricity, suddenly your cost of heating is going to increase by 4 or 5 times to do that. So they don't tend to be widespread. They tend to be, again, another niche product where there are site specific considerations to take into account for those. Um, so that tends to be why they're not seen that often, and actually you'd be better off with an air to water based system or a gas hybrid or a high temperature system in that case, because it would be a lot cheaper to run than an electric boiler. And that is the end of me blabbering on, and hopefully enough time for questions or for Marie to jump in and say I've missed something.
Thank you very much, David. That was really, really fascinating, actually. And I have some questions as well
All right.
from my perspective. But I mean, if everybody, if you would like to unmute yourselves, I can unmute you all. Um, if I can do that, if you can unmute yourselves. Yes, and yeah. forward your questions to David. Also, Steve as well is here from the Community Buildings Network. He leads the Community Buildings Network. So if you've got any questions about your community building as well, please. I can't see who's. I literally my view changed, and there was two people with your hands up straight away. Um, um, Richard, I think, had put his hand up. So if we
Oh,
go with Richard first, and then
okay. Hello, Richard. I'm Porlock near Minehead. Thanks for that information. Number of things we've already done, and but I got two specific questions for you. One is on the lighting. A number of strip lights in the hall using the old-fashioned well strip assemblies. What's your thoughts on changing those to LEDs? Cost, height, installation all come into the equation. And secondly, men's urinals, water consumption. We have a sort of water miser fitted, but nevertheless, our water bills are still quite substantial. We're paying about £700 a year for water, and it just seems. Any thoughts on changing to waterless urinals?
Okay. Yeah, the lighting, I mean, the lighting kind of financially, I suppose, payback will be based on your burn hours. So how much you use that space. The more you use the space, the quicker the payback tends to be because the fluorescent tubes tend to be quite a high wattage compared to the LED strip lights. Is it a kind of plastered ceiling or a grid?
Plastered ceiling, two halls. In the main hall, probably about 14 single 6 foot strip lights, and a smaller hall, probably about 10.
Yeah. Okay. I mean, the ideal, I guess, is if you've got your preferred electrical contractor who comes around and does work for you anyway, is to ask them to give you a quote. But yes, um, it would be a good idea to change them over to LED lighting. If you're doing that anyway, if they're going up there and changing the lights, if you wanted any changes to the kind of the way they're switched, you could do that at the same time. If you use kind of half the hall and not the other half for certain things, then perhaps you could think about kind of changing that over as well. But it's certainly the right thing to do. Um, on the water, it would possibly be worth again speaking to the water company and explaining to them whether you feel that water bill is higher than you expect, and is there a leak in the system? So they can normally come around and test.
We know that. We keep an eye on the meter.
Right, okay, no leak in the system.
No, no, no.
Right, okay, fine. So
It's
yeah,
well used.
waterless urinals, yes. If I'm honest, I don't know the cost of installation of a waterless urinal, and how much that would be, and therefore
Okay.
a payback on how much that would save you every year if you didn't have them. But they're very commonplace now, so they're much more kind of a mature technology, let's say, than they were 5 years ago. And I haven't heard of any stories of people complaining about odours like they did when they first came out. So yeah, certainly want to investigate. I'll probably go away and investigate myself on that as well. Thank you.
okay, thank you. I know Michael Scott's hand up. Andrew did have his hand up at the same time as. So if we can go to Andrew. Oh, you're muted, Andrew. If you could unmute yourself,
Is that better?
that's better.
David, Andrew from Yarnington Village Hall. You touched on a PV system heating hot water.
Yeah.
What would your view be on using a PV system with batteries, combining it with a heat pump?
Yes, absolutely. So yeah, so it's yeah, it all works. It's really that balance. So the PV system, I suppose it's kind of going through the design process. If you're moving to a heat pump system, what type of heat pump and how are you looking at using that? If it's air to air, you can also use it for cooling in the summer. Not that you tell that many people, but that can increase your consumption in summer. But equally, if the PV is sized to meet the majority of the needs of that heat pump system, you could essentially run a building heating and cooling all year round for little cost. Um, the PV system, yeah, so you could size your heat pump and try and understand how much consumption that's going to use over a year on a kind of an annual demand basis, and then size your heat pump accordingly. And then you can get a hot water system depending again on the use of your building and how much water you use and how many sinks, etc. there are.
We've got we just installed an instantaneous electric water heater, so it only heats the amount of water that
Yeah,
we use. So I would envisage that a battery powering that or a PV system
yeah. So the
as and when it's needed.
yeah, the batteries are very good. They're not like I always compare it to like a water butt. So you can fill them up with a PV, fills them up in the day, and then you get your water butt. And actually, when you turn around and say, "Oh, I'm going to turn my heat pump and my hot water on now, and I need 5 kilowatts instantaneously," you can't just tip the water out. It's throttled, so it's like the little tap at the bottom of the water butt that you can't
Yeah, I
just go,
understand.
"Oh, I'll turn it on now." So it you need to understand how much those batteries can push into your heat
Yeah,
pump or
yeah,
electrical
yeah.
system at any one time.
Link to my question. We renovated our hall. We've done two lots of renovations. The main part of the hall we renovated about 10 years, 15 years ago, and we sort of future-proofed it in that we put an underfloor heating coil into the concrete slab.
Right.
Although at the moment it's not actually connected to anything. It's all the tails are in a box
Yeah.
with a view that, at some stage in the future we might use it to connect to a heat pump or a ground source heat pump.
Yeah.
Um, the hall's roughly 10 meters by 5, so it's not huge.
Yeah.
My kind of thinking really is that an air source heat pump, air to air, is going to be a lot better than trying to heat water then to heat the slab. Have you got any views on that?
Yeah. It's always difficult when someone's come up with a great idea of doing something for future plans, and then you kind of turn around and go, "Oh, is that the right thing to
It
use?"
was me that did it, so I've only got myself to blame.
Yeah, it's difficult though because probably at the time it probably was a good solution, and I'm sure there was some good logic behind it, and it's the same everywhere. Things move and things become you know trendy or their niche at that point in time. They kind of everyone's currently doing this and everyone's currently doing that. In 5 years' time, it'll be something different again. Um, so um, yeah, the air to air. I think it's probably a bit of a desktop kind of scratch your head and see what the numbers come out to look like. And again, it depends on the use of your building. If it's continually used or you're continually keeping it warm, actually an air to water based system with the underfloor heating is probably pretty efficient. The other thing you could do is if you put batteries in and you have solar PV, is if you had kind of an intelligent tariff or an overnight economy 7 tariff, you can charge your batteries overnight at 7p
Yep, I understand that, yeah.
and expend them in the day as well, as your solar PV to kind of try and make those finances work better. Um, yeah, the air to air versus the air to water with the underfloor probably depends on how much you use that building and a bit of kind of capital cost head scratching to see what the best solution would be. Does that not really answer your question, but does?
No, they're imponderables that we've been going through. So it's interesting to hear somebody's view.
Yeah, it's difficult. I go to a lot of buildings. They say we put this system in, and you kind of think I can say the easy answer, which is yeah, carry on using it, it's fine, or you can have the hard answer, which is just because it's there doesn't mean you have to use it. Is it the right solution?
Yeah, I mean, at the moment we've got two panel radiators with fans on
Yeah,
that we're using. The halls it's not in continuous use, so it's probably the best way of heating it at the moment. But I'm thinking that maybe one of the simplest sort of systems would be to have a PV system on the roof with batteries and carry on using the panel radiators.
yeah, why not? Yeah, it certainly works. With all these things, I think it's speak to your local kind of contractors because they're the ones who are they're the ones who have got the local reputation, who want to come back, who want to do a good job. and get a couple of quotes in and speak to them about the kind of the various um, thoughts you're having and get some actual figures down as well, so you can make an informed judgment
Thanks. Yeah.
on that.
Lovely. If we could go to Michael now, Michael. Okay.
Thank you. Yes, I'm Michael Fox from Open Doors in Crewkerne. We've just taken on a small space, 9 meters by 4 meters, which we are currently heating with electric radiators.
Right.
We're in there 3 mornings a week. We are renting. We're not quite sure how, we're a small group, which we think we're going to expand. And so I'm just wondering if the investment, obviously investing some of that air-to-air heat pump would be quite expensive. But do you think the costs of heating at that space is it's 6 hours, 3 times a week for 6 hours, and then every other Saturday, and also we're going to be renting it out for events as well. So it's going to be a fair amount of use. Do you think we're going to see enough of a saving over electric radiators to justify investing in what is not our home forever?
Probably on balance, not. I think if you are considering being in there kind of longer term, I guess there's a couple of things in there. There's how long's your lease agreement going to be or your rental agreement going to be? How willing is the landlord to improve that space? Because ultimately it's their demise and their dilapidations at the end of it. Are you, can they meet you halfway, or can they install all of it if you sign up to a longer, lease term with them and say we'll sign up for 10 years, but you need to put in this system for us. But I'd probably kind of live with it for a year, I suppose, and get 12 months worth of data. So look at your 12 months, when you get there, and say, right, last year we used £1,000 of energy, £1,000 of electricity. Okay, even if I can save you 50% of that, I'm going to save you £500 a year. So when do you want that financial payback? Does that need to be within 5 years, 10 years? It's probably going to be quite punchy to try and get your payback within a reasonable lease agreement in that space. And I'd also expect the landlord to front up some stroke all of the costs because it's their space. They're gonna get the longevity from it. But they might turn around and say, well, we'll put it in, but you're getting the cost savings from it. There's different ways to kind of skin a cat there, but I would keep my powder dry. I'd gather the 12 months of data and see where you are in 12 months' time and say, this is how much we spent on energy last year. And I think the best thing to do in the space you've got is probably make sure you haven't got drafts coming in. Make sure you haven't got kind of uncontrolled ventilation gaps anywhere.
We're working on that. Yeah,
trickle vents that are left open. You want ventilation, but you want to be able to control when you bring it into the space and when you don't. And then it's just control around making sure users make sure they turn everything off at the end of it. Don't leave things running. Don't have unnecessary energy wastage in that space because it's obviously quite a small space. So I'm imagining it's probably not going to consume that much electricity anyway.
Yeah, we're hoping. Yeah.
And are the panels thermostatically controlled, or are they just on off and you have to kind of turn them off?
No, they've got thermostat. All the radios have got thermostat, so they're coming on, and then when the room's warm enough, they turn off, or we turn them off. I mean, it's
So it's kind of setting those parameters up right, so they're not set to heat to 23 degrees. They're set to ideally kind of 20, whatever you can get away with. What's the lowest heat you can get away with for the best cost? But
absolutely,
you want people to use the space. I get that. It's a balance, isn't it, of making sure people are warm and welcome, but making sure that it's not so hot that people then start opening windows.
Yeah, well, we've only got no windows. We've got a huge window at the front, a sort of picture window, which I was looking at secondary glazing. But again, the cost of secondary glazing is in the hundreds, and if we're not there for very long, we need to wait. I think you're right. I think a year waiting is a good idea. Thank you very much.
Yeah, and I think if you get problems with that the window, you can get kind of temporary. I don't know how big this picture window is, but you can get those temporary kind of like cling filmy solutions, which you can put on. The other way is if people are complaining it's cold draft dropping from that window. Some buildings I've seen have put like a lip at the bottom. They just like DIY'd a kind of a small lip to stop the air just dropping straight down to try and break that airflow. I don't know whether that
Thank
helps
you.
or not.
Great.
Lovely, thank you. I noticed that time's ticking on now. I don't know if anybody has any other questions for
Yep.
David or Steve.
Yeah. Yes, please.
Lovely. Okay, fire away. Okay. Do you want to unmute yourself, Tony? Do you want?
Yes, can you hear me?
Yes, we can hear you. Yes,
Yeah,
fire
yeah.
away.
Sorry. Well, David is going to come and do an audit in our building, which is Culford Youth and Community Hub.
Right.
And so I hope to be able to ask you specific questions then. Now, we have an issue at the moment because we use a lot of electricity because we have a pop-up cafe that runs 3 days a week and another day used for preparation. And we're considering changing our cookers from currently electric to possibly gas. Do you have any views on that, or is that beyond your remit?
Not beyond the remit. I suppose my exam question is I'm trying to decarbonise you, not to incentivise you to use more carbon. So, yeah, kind of cafes and chefs like gas. It's kind of an instantaneous, but it is a fossil fuel. So, it's difficult to say you can move from electric to gas. Is the right thing to do. What I can say is if what you're using at the moment is uh, a standard hob, would be the better thing to do would be to move to an induction hob.
Yep.
Because they're much more akin to the gas kind of responsiveness. They only heat when you put the pans on them, and they're not like the kind of standardized hob where they just stay hot for hours afterwards. They're not very responsive. They're pretty rubbish to cook with. So my inclination would be say, could we move to an induction hob rather
Okay,
than
because
a
then
gas?
that would tie in with the long-term hope that we would get a PV system,
Yes.
and so we'd be mainly using electricity rather than gas.
Absolutely, and you could use that PV system and the batteries like we've discussed previously to try and help support the use of the cafe.
Okay,
The cafe stuff will be quite punchy. The equipment used in catering kitchens is high power, is power hungry.
yeah. Okay, thank you.
Okay, well we can chat more when I come and meet you, Tony.
Yeah, thank you.
Okay. Andrew.
Very, very, very
You've got
briefly, it's a question for Marie and for David. Um, yeah, as you gather, we're considering a PV system for our hall. Are there any current funders that you can recommend applying to?
Marie, over to you.
Well, thank you. Actually, I might hand over to Steve on that one because Steve is our expert on funders for community buildings and puts together the tailored funding plans. And I think he has just done one for community buildings members. So, Steve.
Yeah, I think I won't kind of lie and say that I think funding at the moment in the current climate is becoming more and more challenging across the board. The pot of money that we had last year that some people were, able to access from Somerset Community Foundation, that's not been replaced. There's at the moment, there's nothing come out again to say that anything like that's going to be available. There are funds out there. They're highly competitive. Many of them will require you to probably have a contribution or match fund it as well. So I am trying now to say to people, you need to think about how you can raise that money if you don't have reserves for match funding as well. I spend quite a bit of my time trawling and putting together, like Mary says, for the community buildings that are part of the Thrive network, putting together resources to give people information on what funds are currently available. And I have that available as part of the Thrive members network, constantly looking at it, seeing what's out there. And at the same time, some of them, as quick as I kind of find them, they've gone as well. So again, it's just pointing out to you that Some of them will have a timeline on them, and a lot of them now operate as soon as they've met their kind of needs. They've got enough applicants, they shut them down very, very quickly. So it is rapid. Some of the usual funders are out there, potentially National Lottery and some of the things associated with, especially with the heritage buildings, looking to improve those. But again, it's highly competitive. So I think in the instance of looking for funding, I can point you in the direction of who is likely to fund you. But at the same time, I think now you've got to kind of be on it yourselves and keep up to speed with what funding is out there. Most funders will want some form of energy check, a decarbonisation plan as well. We're finding that most funders will want to know that you've done all of that background legwork as well, so that you've kind of made your building as good as you possibly can at that time. And they will also want to see commitment that you've got kind of usage, that you can demonstrate the usage patterns, how much the building is going to be used, whether or not the investment's going to improve the use of it as well. And that equally, what we're also finding that a lot of funders also now want you to be able to demonstrate that you've gone through consultation with your users in your community, so that you can really demonstrate that you've got that buy-in. So that's where we're at now. That's the advice that I would give you at this point. I've got a massive a pretty decent funding list of who's out there. It's pretty much as good on the day that I do it, because it changes within 24 hours.
Doesn't it ever?
So does that help?
Yes, thank you. Yeah.
I've put a link in the chat to the it's not just decarb resources, actually. We've got a toolkit online on the Thrive website, a lot of our decarb resources, but there's a lot of other information there for community buildings as well. There's also filmed training, like training that Dave has done today, and information workshops around consultation and putting together a bid and what funders might be looking for. It is worth digging into that if you are wanting to put together funding applications and you haven't done one for a few years. And also obviously about community consultation as well, different ideas about how you might do that. I mean, you're probably already doing it with your halls, I would imagine, but there are some other suggestions there on the website as well. So does anyone else have any more questions for David or Steve before I wrap up?
I was just going to add, Mary, as well, that if you haven't, I know that, obviously a part of the Decarb programme, we've been fortunate to fund some DIY, the energy audits that David's doing. At the same time, I would also recommend that if you haven't, if you're looking again for funding, that if you haven't got an energy audit in place, it really does help you make sure from people like David's skills and expertise that you are making the appropriate best choices for the long-term plan of your building. And again, it will make your funding application more attractive to funders, just due to the high competitive nature out there at the minute. It's huge, the amount of applications that are going in. I trawl through as well and look through some of the applications that have been rejected, and it's phenomenal. The amount of applications that are going in that are incredible applications that are just not getting funded at the moment as well. So again, just be aware of, you've got to stand out, I think is the nicest way of putting it.
And I think the other thing, certainly from the process of, going through, supporting buildings through decarb and putting, getting people to the audit stage, the audit application stage, is telling the stories of your users and stories of the hall, not the hall's falling apart, we need this, but the stories of the users are kind of what funders really, really like to see. They like to be told, the story of the users and your own community as well. So I think we're going to have to, because we've gone a little bit over time now, and I'd like to say, if you've got any more questions, I'm going to be sending you the slides from today, and please do get back in touch with me or forward your questions for David via me. And I would just like to thank you very much, David, and Steve, for coming along today and for your combined knowledge around buildings. What I would say is there's still a little bit of time left in the Decarb Somerset programme for some one-to-one support with me. If you haven't already received that, we've got a small amount left. I've got a finite number of hours now, literally got about 3 or 4 days left before the end of February. I've put a link to the toolkit in the chat. As Steve said, if you can get yourself definitely a DIY energy check. I had a building that had made lots and lots of changes recently, had a couple of lottery grants for changes, very successful there. They did a DIY energy check the other day and their feedback was amazing. They found things which they hadn't considered before, just through doing that check. So it is worth doing. They also have done a carbon reduction plan with us as well, and that is another very strong piece of evidence for funders as well about your intentions moving forward. We've got these comprehensive templates in the toolkits that you can work from, but you can also ask me if you want the full templates. They're not all up on the website. If you want full templates for the carbon reduction plans, get in touch with me, reply to my email. I've got a short poll. If I could just ask you, if you don't mind, just to give us a little bit of feedback, only a couple of questions today. If I could just run that for you, please, that would be great. Thank you. That's lovely. Thank you, everybody. Just to mind if I don't just screen grab that in a minute. I'll end the poll there. That's lovely. If I just share your results, and hopefully most people have. But who hasn't increased your confidence, if you can get in contact with me directly, and I will, if you're not part of the program yet, I can do a one-to-one with you. The other thing I'd like to add at the end is there was an offer today of people who signed up. We had some Screwfix vouchers which we had last year from one of our events for Energy Saving Week, and we've offered those remaining vouchers out today to people who haven't had one before. I will be in touch with you if you're qualified for a voucher. You do need to be part of the Decarb programme and have signed up for it in order to get that, because we need to demonstrate to the funders where we're sending things. So please do reply to my email or look out for my email today. Okay, I just want to say thank you to David and everybody for coming today. Thank you.
Thank you.
Thank you.
Thank you.
Thank
Thank
you.
you.